Good morning everyone. In today's lecture we will start the third chapter is given in unit number 3, slope and deflection of beam. Okay. Then we will start what is meant by slope and what is meant by deflection. We will study in the unit number we will study here in this unit slope and deflection. How to find out the slope and deflection. It will consider any type of the beam. We have seen the different types of the beam in the unit number 2, right? And there is a different loading on that beam. When you are applying the some load on the beam, then this beam will be bent. Okay. Then we will get the slope and deflection in this beam. We want to find out slope and deflection in that beam. Okay, here see I have drawn the simply supported beam. Okay, the support RA and RB, and when you apply the some load on this beam, then this beam is deflected from its original position and will get this curve. This curve is called as a elastic curve. Remember that this curve is called as a elastic curve. And what is meant by slope? First we will see the definition of the slope. Slope at any point in the beam is defined as the angle is in radian. The angle is in radian. To draw the tangent to the elastic curve. Okay, the tangent to the elastic curve at that point and original axis of the beam. Okay, angle in radian in between tangent to the elastic curve at that point to the original axis of the beam is known as a slope. This what if you have drawn the tangent to that elastic curve anywhere at any point, okay, and if you have taken the axis of the beam, original axis of the beam, this distance is given the slope. It is denoted by what? All of you getting? It is denoted by we can say the symbol. It is denoted by the theta, or we can say the dy by dx. Slope is denoted by the theta or dy by dx. And what is the SI unit? SI unit of the slope. SI unit of the slope is radian. Know how to convert it to the degree, to radian or radian to degree. All of you getting the what is meant by slope? The angle is given in radian between the tangent to the elastic curve at that point to the and the original axis of the beam. This is called slope. Then what is the deflection? What is the deflection? See here I have shown here deflection of beam at any point. Deflection of beam at any point is defined as the distance between the elastic curve that point to the original axis of the beam. Okay, you can choose any point and find out the deflection. Suppose here I want to find out deflection. The deflection in between the elastic curve and the original axis of the beam. Okay, is known as a deflection. Okay, second is a deflection. Okay, all of you getting what is meant by deflection, and it is denoted by the symbol. We can say the deflection is denoted by the y, or some books you have given the symbol delta, or we can say the del is there. Okay, del is there. Use any one notation. We are using the y notation to find out the deflection. And what is the SI unit? SI unit is a mm meter. Okay, all of you getting what is the slope and deflection? We want to find out in this unit slope and deflection of the beam. Okay, and how to find out that slope and deflection of the beam? We want to check first boundary conditions. Okay, for there are two boundary conditions are given for the simply supported beam as well as cantilever beam. Check that. I have considered here one is the simply supported beam, another is a cantilever beam. First we will see the boundary conditions for the simply supported beam. Boundary conditions. Check that at the support deflection is always 0. Okay, if you have considered the simply supported beam, what is the first boundary condition at the support? That's simply supported beam. Okay, deflection is always 0. How much deflection will get at the support? Deflection is always 0. Always 0. Okay, remember that first boundary condition at the support. Check that. Here you have to consider the deflection is always 0. Then what about the slope at the support? Again, check that at the support. What is the how much slope will get the slope is always maximum. Slope is always maximum. Slope is always maximum. Slope is always maximum. Remember that at the support there will get the slope is, if you have checked at both sides. Okay, if you have drawn the tangent here, you will get the slope is always maximum at the support. And last is a where the maximum deflection is occurs. Maximum deflection is occurs where slope, how much will get the slope, where will get the maximum deflection? Suppose this point will get the maximum deflection. What about the slope? If you have drawn the tangent to that elastic curve, then there is a no slope, means 0. Maximum deflection occurs where slope is 0. Slope is 0. Okay, all of you getting? You have to remember that three boundary condition. I will repeat that. At the support, check that deflection is always 0. At the support, slope is always maximum, and maximum deflection occurs where slope is 0. Slope is 0. This is for three boundary condition given for the simply supported beam. Then what about the cantilever beam? If you have considered the cantilever beam, when you apply some load on that cantilever beam, this beam is deflected from its original position. I have drawn here one tangent and shown the slope and also deflection. Then what is the first boundary condition? Check that at the free end, both slope and deflection. What is the value of slope and deflection at the free end? Slope and deflection is always maximum. Is always maximum. Okay, you will get the maximum value. Check that. Here is this beam will depend in this way. Then here you will get the y max value, and here you will get the theta max value. And what about the at the support? At the support, what is the value of slope and deflection? At the support, check that. Here is what is the value of slope? Slope and deflection is always 0. Slope and deflection is always 0. Slope and deflection is always 0. Yes, getting? Yes, remember these two boundary conditions. We want to the why we require the boundary condition. When you find out the integration constant c value, at that time we want to use the boundary condition and find out the c value. Okay, all of you clear? Check that. You have to remember the figure. With the help of figure, you can easily explain. Then next, which method is used to find out the slope and deflection? There are 4 methods are given in your syllabus. There are generally 4 methods are used to find out the slope and deflections. We will see the methods. Okay, there are different 4 methods are given. First is a double integration method. Okay, you can find out the slope and deflection with the help of a double integration method. Double integration. Second is a Macaulay method. Macaulay method. Macaulay is the name of the scientist. Macaulay method. Okay. Then third is a conjugate is there. Okay. But before going on the conjugate method, there is a one more method is given. Movement area method. Movement area method. Okay, this is the movement area method. And last is a conjugate beam method. Okay, with the help of these four methods, you can find out the slope and deflection. But if you have seen in your syllabus, there is a only one method is given, Macaulay method. Macaulay method. Here we will study only the Macaulay method. Okay, this double integration method is also same as a Macaulay method. But we will see the Macaulay method. But you should remember that four name: double integration method, Macaulay method, movement area method, and conjugate beam method. Okay. Then next. See, you have given the differential equation derivations. Okay, you should remember that equation. Okay, only one equation you have to remember. Okay, but I will explain that all equations. EI into d raised to 4y divided by dx raised to 4. Okay, what is the meaning of that? Is equal to minus w. Minus w is related for the rate of loading. Rate of loading. Okay, you have to remember that equation. Okay, this is the rate of loading. Integration is given with the help of that elastic differential equation. Okay, differential equation. You will get this formula: EI into d raised to 4 by y by dx raised to 4 is equal to minus w. Okay, if you have taken the integration of this, then again you will get EI into d cube y divided by dx cube is equal to s. S is denoted by pi for what? Shear force. You will get the shear force. Then again, if you integrate that, then this formula we are using by Macaulay method. Macaulay method. Okay, which formula? If you are using, again taken the integration of that, then you will get the EI into d square y by dx square. This formula you will give the, this is the bending moment. Okay, this is very important. We require this only one formula to find out the slope and deflection. Remember that EI into d square y by dx square is equal to m is there, bending moment. Again, if you have integrate this equation, then you will get the EI y is equal to EI y is equal to, you will get the deflection. This is the deflection. Y means what? You will get the deflection of the beam. Deflection of the beam. Okay, all of you getting this formula will require in the Macaulay method. Deflection of the beam. Okay, m is the bending moment. EI into y. If you have integrate this equation, then you will get the deflection of the beam. You should remember this too. I have explained this also. What is the EI? EI is the flexural rigidity. EI is the flexural rigidity. Flexural rigidity of the given beam. Okay, E is the modulus of elasticity and I is the moment of inertia about the section x-axis. Okay, this is called flexural rigidity. Okay, then next how to find out or how to solve the numerical with the help of Macaulay method. We'll check that. All of you getting? You should remember this two formula only. EI into d square y by dx square is equal to m. Okay. The next one is a Macaulay method. I I will explain with the help of any one example this Macaulay's method. Macaulay's method is used to find out Macaulay's method is used to find out the slope and deflection value. Okay, I will consider here simply supported beam. Okay, I will explain the steps. You have to remember the steps. With the help of that steps, easily you can solve the given numerical. Okay, here I will consider the one simply supported beam. A point, B point. Here you will get the reaction RA and RB is there. Right? A is there, B is there. Okay. First I will apply the load W at a distance A1 from the left hand support. Then again W1, W2. Okay. W2. This distance is a, I will consider A2 and here is a W3. Okay, again I will consider this distance is A3. Okay, and this total span of the beam I will consider the L. Okay, I have taken this example. I have considered the simply supported beam. Also I have considered the distance from the left end. You can consider from the right end also, no issue. You will get the same answers. Okay, then what is the Macaulay's method? First step in the Macaulay's method, you have to calculate the support reaction, and we have seen this thing in the unit number 2. Okay, first is the determine support reaction. Okay, once you have calculate the support reaction RA and RB, then next step is consider. You have to consider. Okay, not right here. I will explain. You have to consider the section XX at a distance X from the left end. Okay, from the left end. This is very important. You have to consider the section XX at a distance X from the left end, covering all types of the load. Check that. Where is the load? Here. I have covered the all types of the load, and you have to consider that section XX at the last section of the beam. You can consider here also that section XX from the right side. You will get the same answer. Okay. You have to remember anyone. You have to consider the section XX at a distance X. Consider section XX at a distance X from the left end, covering all types of the load. Okay. Once you have to write that, then third step is that take a movement above that section XX. Take a movement above the section XX. Okay, next step. This is very important step. You have to take a movement of all forces about the section XX. Okay, we have seen that there are two sagging movement or hugging movement. Okay, you have to consider sagging as a positive and hugging as a negative. Already we have seen. Okay, then what you will get if you have taken the movement about the section XX? Then check that. You will get, I will write here that equation. Moment about the section XX. Okay, when you take the moment about the XX, don't know the RA. RA into X is there. RA into, I will write X. Okay, then make the compartment. Okay, you have to make the compartment after the loading. Here is the one load, then make the compartment. Then easily you can solve the given numerical. RA into X minus W1 minus Y. This is going anti-clockwise. Minus W1 into, how to calculate this distance? Yes, anybody? Total distance up to the section XX. Yes. x minus a1, then you will get this distance w1 to the x minus a1, right? This is the x minus a1 moment about the section xx. Then second compartment again minus w2 into x minus a2 is there, right? And third compartment x minus w3 x minus a3. Okay, this equation is very important. Okay, if you are doing the wrong thing in that equation, then you will get the wrong answer. Slope and deflection also wrong. All of you getting how to calculate that? We have seen in the unit number 2 how to take the moment about the section xx. Okay, same thing, only you have to do the compartment. Compartment, why compartment? Because if you have taken the compartment, then easily you can solve the given numerical. Then next thing is you have to use the differential equation of the deflection. We have seen differential equation of the deflection. Differential equation of deflection. What is the differential equation of deflection? We have seen m is equal to d square y by dx square into ER. Okay, use that equation. Okay, put the value of m and x is here, then this equation as it is. Okay, then next is I will put this value. Okay, steps number what? 4 number. You have to remember that differential equation of the deflection. Okay, then what is the mxx? I will write here d square y by dx square into ei into d square y by dx square is equal to, I will write ra into x and compartment minus w1 into x minus a1, then next minus w2 x minus a2, and then next minus w3 x minus a3 is there. Okay, this is the equation number 1. We can say this is the equation number 1. This is the general equation. Okay, with the help of that equation you can find out the generalized equation for the slope and deflection. Then what we do in the step number 5, integrating this equation number 1. If integrating equation 1. Okay, with respect to x again. If you are integrating that equation, then you will get the ei into dy by dx is equal to ra into x square divided by 2. What is the integration of that x? X square divided by 2 plus integration constant c1. Okay, note that you have to write in the first compartment integration constant c1. Integration constant c1. Okay, then minus w1, keep as it is this bracket, x minus a1 bracket square divided by 2 is there. Then next minus w2 x minus a2 bracket square divided by 2, and third is a minus w3 x minus a3 bracket square divided by 2 is there. This is the equation number 2. What is the dy by dx? We have seen in the definition of the slope. It is denoted by the slope. Okay, you will get the generalized equation for the slope. And if step number 6, again if you are integrating that equation number 2 with respect to x, then which equation you will get? You will get the deflection equation. ei into y is equal to ra into, I will write directly, x cube divided by 3. 3 into 2 you will get the 6 plus c1 into x plus second integration constant. Remember that when you find out the deflection, then you will get the two integration constants c1 and c2. When you find out the slope, then here you will get the only one integration constant. Okay, then minus w1 into x minus a1 bracket 2 divided by 6 minus w2 into, I will write here, 2 is there, minus W2 x minus A2 bracket cube divided by 6, and last is the minus W3 x minus A3 bracket cube divided by 6. This is the equation number 3. That three equations are very important. Equation 1, equation 2 and equation 3. This two, equation number 5 and equation number 6, this is the generalized equation. Okay, once you have got the generalized equation, then next step number, I'll write here step number 7. You have to, how to find out the constant value. We have seen the boundary condition, right, for the simply supported beam and cantilever beam. You have to use that boundary condition and find out the value of constant. Use boundary conditions or apply boundary conditions and find out the constant value. Find C1 and C2 value. C1 and C2 value. Once you have got the C1 and C2, put this value in that equation. Okay, step number last 8. Put C1 and C2 in equation 2 and 3 will give slope and deflection value. Slope and deflection value. Okay, all of you getting? You have to remember that 8 step. I will explain that steps again. See, first step, you have to calculate the support reaction. In the second step, you have to consider the section axis at a last compartment of the beam, covering all types of the load. Okay, from the left end. Then third is a take moment about that section axis. You will get the one equation. M is equal to Mxx is equal to this equation. Okay, we know the differential equation of the beam. Use that differential equation and put the value of Mxx is equal to d square y by dx square into EI. Okay, this equation you will get the first equation. And if you are integrating next steps number 5. If you are integrating that equation, then you will get the generalized the slope equation. Again, next step, if you are integrating that slope equation, then this equation will give the deflection equation, means y equation. Y is equal to. Okay. Next steps, you will get the constant in the generalized equation 2 and 3. How to calculate? You have to use the boundary condition. You have to apply the boundary condition. Okay. Once you apply the boundary condition, then you will get the value of constant C1 and C2. Put last step, you have to put that value in the equation number 2 and 3. These two equations, you will get the value of slope and deflection. Okay, that's it. Okay, if you remember that this method, similar way you have to go and find out the slope and deflection value. Today we will stop. Next lecture we will solve the numerical solve that.